Good. So let's just tabulate the typical properties of these gyres and boundary currents. We'll learn a little bit more, but you have the North Pacific gyre, you have the North Pacific current as a Kuroshio extension, you had the cold California current coming down along the west coast of US, coast of California, you had the North Equatorial Current to the south in the deep tropics, and you had the Kuroshio current. Actually, it's not Kuroshio current, it's a Japanese name. In Japan, it's pronounced as Kuroshio. I'm just joking. Kuroshio in Japanese means black current. So we don't need to say Kuroshio current, we just say Kuroshio. Kuroshio is called a black current because these western boundary currents, they are not very productive. Japanese love their fish. If there is no fish, they're going to call it useless current, but it actually brings a lot of good weather, warm weather and rain to Japan. So western boundary current called Kuroshio. In the Atlantic, you have the North Atlantic current, Canary current, North Equatorial current, similar to the Pacific, and you have the Gulf Stream, the most famous of the western boundary currents that we'll learn a little bit more about. Indian Ocean gyre, as we said, is in the southern hemisphere because the northern hemisphere has complicated circulation because of the monsoon, as we will see. It has the South Equatorial Current, just like the South Pacific and South Atlantic Oceans, has the Agulhas Current running between Madagascar and the East African coast, has the so-called west wind drift in the edge of the Southern Ocean into the Indian Ocean, and the West Australian Current, which is also unusual, as we will see when we look at the details of the Indian Ocean circulation. Similarly, you have other currents in the subtropical gyres and other major currents in each ocean, like the equatorial countercurrent that we talked about, the Alaskan current in the Alaskan Gulf of Alaska, Oishio current, the cold current coming down, and the Labrador current in the North Atlantic. You have the Florida current, East Greenland current, and Falkland current, and you have the equatorial countercurrent, North Equatorial Current, so-called South Monsoon Current, the Lewin Current, which is the eastern boundary current along Australia in the southern hemisphere, and the Somali Current, which is of course along Somalia, that we'll see. So these make for some very specific features. So equatorial currents are the north-south and the north or south of the equator, and the travel westward along the equator driven by trade winds. Western boundary currents typically carry warm tropical waters to mid-latitudes, or they're carrying cold polar waters down into mid-latitudes, like the Oishio current and Labrador currents are coming south, whereas the Gulf Stream and the Kuroshio are going north, right? Subtropical gyre currents, we already talked about. The other surface currents, we already mentioned. Subpolar gyres, not as large as the subtropical gyres because the Earth is a sphere and begins to become smaller and smaller as we go towards the poles. Okay, so a lot of things to remember, but don't worry, we will look at these things again and again. And the main thing is that you need to now again carry all the concepts, especially because we are going to add chemistry and biology to this, so you will have to be able to remember the profiles of carbon dioxide, oxygen, nutrients, and then use the currents, not only surface currents but deep currents and vertical motions, to see how biology is affected by ocean currents. Okay, fun.